Hey folks, how we doing? All right, we are talking about Pythagorean theorem. This is our test review for topic 5. So we look right here. What is the distance between points C and D? Right here, okay? So the idea here is we're going to use the Pythagorean theorem to do this. So I like to draw a right triangle on here. It's not a great straight line, but what are you going to do? Again, Pythagorean theorem is a squared plus b squared equals c squared. You can think of that as leg squared plus leg squared equals hypotenuse squared. Okay, so this is a, that'll be b. I like a is the short one, b is the medium, c is always the longest side, but you can flip-flop those if you want. So then the distance here, we'll just count it on the grid. So 1, 2, 3, 4. So that's 4 by 1, 2, 3, 4, 5, 6 right here. So 4 and 6. 4 squared plus 6 squared equals that hypotenuse, which is that long diagonal side, that's c squared. 4 squared is 4 times 4, which is 16. 6 times 6 is 36. And then we bring down that c squared. We add these two together, 36 and 16. 6 plus 6 is 12. Carry the 1. And then 1 plus 3 plus 1 is 5, sorry. So I got 52 is equal to c squared. Now we got to figure out what just c is. So we square root here and we square root here. We'll just use one of these blue calculators to do the square root of 52. 52, and then the square root is right there. So right there gives us 7.2. So C is 7.2. Just like that. Okay. Define the following. Rational number is just can be turned into a fraction. Can be turned into a fraction. Okay, examples of this, what did I put on my guide here? Anything that's repeating, like that, right? It could be 6.2, it could be, I don't know, 8.13. Those can both be turned into fractions. We haven't talked about it yet, but it can be. Anything that's like a perfect square, so like the square root of 100, that's going to give you 10 as a whole number. Anything that terminates or ends, like something like this, where it just stops and doesn't repeat, you can turn that into a fraction. This would be 2,781 ten-thousandths if we turned it into a fraction. Just like that. Let's see. Oh, fractions, right? Because just like that, those are rational numbers. It's already a fraction. Irrational numbers is can't be turned into a fraction. So these are non-repeating, meaning they don't have a pattern. Yeah, we're running out of room here. And then non-terminating, meaning they don't end. Terminating. So something that's not a perfect square, right? So square root of 99, for instance. When we do that, right? Let's see if I can get that on there. 99 square root. That gets us this. And you can see it ends right here, but technically it only ends because the screen's not big enough to continue going on forever, right? So this would be a non-terminating, non-repeating irrational number. So anything that's not a perfect square, and I'll put up my perfect square list actually for the test. But if you don't see this on the perfect square list, that means it is an irrational number. Something like pi is also an irrational number. That's non-repeating, non-terminating, right? So yeah. Solving here, so I think the easiest way is to get common denominators. You could also turn this into a decimal. This gives us 7/10 x minus 5 is equal to 3 times 2 is 6, and 5 times 2 is 10. Again, you want to match the common denominators, so 5 times 2 is 10, and if I'm multiplying by 2 on the bottom, I do that on the top. So that's x plus 2. Now I'll subtract that 6/10 x on both sides. Okay, now 7/10 minus 6/10 is going to get you to 1/10. So 1/10 x minus 5 equals 2. We'll add 5. to get 1/10 x equals 7. And now the idea here is what times 1/10 is 7? In this case, it is 70. Okay, now how you do that, like this 1/10 x is the same thing as x over 10, which is just division, and so the opposite of that is multiplication. So that cancels out, so x equals 70. Two side lengths of a right triangle are given. Determine the length of the third side. So I'm just going to call that A because it's the short side. That'll be B and that'll be C. This is a little funky because the radical symbol, that square root symbol, but it is super, super easy to deal with because we already know what the opposite of square rooting is. We know it's squaring something. So when we plug these in, it's going to be A squared plus 4 squared, that B is the 4, is equal to the square root of 20 squared. Okay. Now, normally, if this square root symbol weren't here, this thing that I'll just do in blue, if this weren't here, it would be 20 squared, which would be 20 times 20, which would be 400. However, when we kind of go to our next step here, 4 squared is, again, 4 times 4, not 4 times 2. What happens with this square root and this square is they cancel each other out to just leave 20. So then we subtract 16. And we get to A squared equals 4, which we square root, and we get to A is 2. Just so we know how to do that, 4 square root is 2. Okay? All right, number 5, prove whether they're triangles or not. Show the work and explain. So for triangle number 1, we say 7 squared plus 10 squared equals 17 squared, right? A, B, C. The long side has to be C, okay? So that's 49 plus 100 equals 17 squared. Again, it's not 17 times 2, it's 17 times 17. It's 289, okay? So when we add those together, I get 149 equals 289. We're testing to see if they're right triangles or not. This is not a right triangle, okay? Show the work and explain. So that's my work right there for the first one, and explain. I know it's not a right triangle. Because 7 squared plus 10 squared does not equal 17 squared, right? You could even say something like 149 does not equal 289, right? And now for number 2, we're going to do the same thing. A, B, C, so that's 5 squared plus 12 squared equals 13 squared. 25, 5 times 5, 12 times 12, use a calculator, is 144. 13 times 13 is 169. Again, use a calculator for this, okay? Add those together, it's actually 169, right? 144 plus 25, add them together, that's a 9, that's a 6, that's a 1, okay? So yes, it's a right triangle, so I know it is a right triangle because 5 squared plus let's actually give a different explanation like this, or a different style of explanation, because 5, 12, and 13 satisfy the Pythagorean theorem. And if you have your work here to support it, which that's part of it, is showing the work, right? Then your explanation and your work together kind of like prove all that. I'm going to, I'll show you my pencil. Okay, so number 6, this is a bit of distribution. So we're going to distribute here. Okay, that we're going to bring down here to negative 12x plus 8. And so now what do we notice? Well, we notice that we have negative 12 on both sides. Okay, with different constants. Okay, and then that 8 and that 2, those are constants. Okay, so if you continue solving it, what happens? I got this negative 12x plus 8 equals negative 12x minus 2. This is a little funky, so I'm going to add the 12x. A lot of you are probably seeing this and being like, oh, I already know the answer. I know that 8 does not equal negative 2, So it's no solutions. But that is kind of how you work through it and how you think about it, or how I think about it anyway. Okay. Leilani planted the tomato plot. It was 5 inches tall when she planted it and grew at a rate of approximately 1.3 inches per month. What is the linear equation? The models the relationship between the number of months that have passed X and the height of the tomato plants in inches Y. Let me grab a highlighter if I have one that isn't dead. Okay. 5 inches tall, grew. When she planted it is in, well, these, I would all underline these because these are the questions, but when she planted it is important, and then grew at a rate of. Okay, those are kind of the important things I would do here, right? So then the first one here, what is the linear equation? Remember, this is going to be in the form of y equals mx plus b, okay? So when she planted it and grew at a rate, when she planted it, that's our initial value, that's our b, and grew at a rate of, that's our m, okay? So when we talk about our m value, right, that's going to be, it grew at a rate of approximately 1.3 inches per month, and our b value is where it started, so 5 inches tall when she planted it. Okay, so when we put our equation together, it just goes in here, y equals 1.3x plus 5. Super simple, right? And you can see that the months that have passed, right, 3 inches per month. That's why the 1.3 matches to the x, okay? And then and the height of the tomato plant in inches, 5 inches tall. That's why it goes with the, like, that's where it starts, right? Okay, if the tomato plant continues to grow at the same rate, when will it be 18 inches tall? 18 inches tall, that should actually be a number, but that's the height of the plant, which is the tomato plant in inches. So this part, again, bullet points, right? 18 is equal to 1.3x plus 5. I subtract 5. I get to 13 equals 1.3x. I divide by 1.3. And, okay, it's important that you put the decimals in here, otherwise you're going to screw this up. 1.3 gets us to 10. So x equals 10 months. Okay, so I did those two. Okay, now I'm just going to go over here for the other bullet points, show the steps you used. Okay, boom. And then last one, state the approximate height of the tomato plant 7 months after it was planted. So 7 months is the x value, right? Months that have passed, 7 months, right? So that's how we can link those up. So when we put it together, it's going to be y equals 1.3 times 7 plus 5. 1.3 times 7, 9.1. Yep, okay. So y equals 9.1 plus 5, y equals 14.1, okay? So let's see, 9.1 plus 5. Okay, you got to match that 5 with a 9, not the 1, otherwise you're going to screw this up, okay? And so let's see, state the approximate height. The plant was 14 inches, because it's approximate, after 7 months. Okay. Okay, moving on. What is the equation that models this function? Find your b first. That's your b. Okay, it starts at positive 1, right? And then your rise over run. Find a point. That's your first point. Find another point that's on the line and on the grid, right? You couldn't do this one here because it's not on a corner, right? So this point right here that's on the line does not work because it's on the corner. Okay. So then you figure out how far you go down. And I'm at -2. That's our rise. Since I'm going down, it's negative. And then for our triangle, right, we go to the right 3. That's our run. And then it's rise over run. So -2 over 3. So when we put our equation together, -2/3 x plus 1. Okay. Alex was trapped in a burning building and Lynette used a ladder 17 feet above the ground. The bottom of the ladder was 9 feet from the base of the building. What is the length of the ladder? That's what it's asking, is the length of the ladder. Above the ground, bottom of the ladder from the base of the building. So we've got our building here. Okay. The window is like right here. Okay. Our ladder is going like this. Okay. So, okay, if you want to draw a lunette on here, it's a bad lunette, but what are you going to do? And then Alex is like, help me, help me. Okay, anyway, so Alex's window, the window right here, is 17 feet above the ground. The bottom of the ladder was 9 feet from the base of the building. So that's our A, that's our B. We're looking for our C. So 9 squared plus 17 squared is C squared. 9 squared is 81. 9 times 9. 17 squared, I believe, is 289. I think we actually had that number on the depth of the problem. 17 times 17, 289. Add these together. 289 plus 81 is 370. Square root, square root. I've already got it here, so I just hit that button and I say, oh, 19. So the ladder is 19 feet long, or should be at least. You don't want it to be too high though, so probably not too much higher than that. Okay. All right. Solve the systems of equations. When it's like this, you take these two and set them equal to each other. Since I have a decimal here and a fraction here, I'm going to convert this to a decimal. How do you do that, Mr. Wishart? Super easy if you don't know it off the top of your head. 3 divided by 4.75. Okay? 3/4 is worth 75 cents. That's how I tend to think about things, like this. Then I'm going to subtract that 0.75x from both sides. Cancel it out here. 2.5 minus 1.75, or sorry, 2.5 minus 0.75 gets us to $1.75. Golly, come on. 2.5 minus 0.75. Okay, so $1.75 left. I know this isn't a word problem, I'm talking about money, but again, that is how I think about it. So add 2 on both sides. 1.75x is 7. We divide by 1.75. So 7 divided by 1.75, 4. Now we plug this 4 in. I think either one, honestly. Yeah, I don't know. If you plug it in here, you get 2.5 times 4 minus 2, or you get 3/4 times 4 plus 5, 2.5 times 4. Going to give us 10. Boom. So 10 minus 2 is 8. Okay. And then 3/4, well, 0.75 times 0.75 times 4 is 3. Plus 5, is 8. Look at that. So our y value is 8. So your solution is 4,8. We want a rate of change of 1/3. So this is the rise. That's the run of both tables. Okay, remember rate of change is rise over run. It's the same thing as slope, right? Or m, same thing, right? So now I figure out what the difference is here. You might look at this one and be like, oh, 1/3, that's what I'm looking for. This is the one. However, these are actually going up by 1, not by 1/3. So these are going up by 1. These are going up by 1 as well. So when you actually put it together as your rise over your run, that's rate of change is just 1 over 1 or 1. That's not it, okay? But this is going up by 1 here and 3 here. So this, your slope, interchangeable, right? Rate of change and slope, m, same thing, right? So that's the one with the rate of change of 1/3. Okay. Following exponential expressions, 5 to the power of 0 is 1, 5 to the power of 1 is 1. 5 squared, which we should know by now is 25, right? So then let's follow that same pattern, right? 4 times 4 is 16. 4 to the power of 1 is 4. 3 to the power of 0 is 1. 3, and then 9, right? If we're multiplying by 5 to get this way, or multiplying by 4 this way, or multiplying by 3 this way, you'll notice that I'm multiplying by the base each time, right? If you reverse it, right, you divide by 5. So 25 divided by 5 is 5, divided by 5 is 1, divided by 5 is 1/5, divided by 5 is 1/25. You can see that once it starts hitting that 5 to the power of 0 and it starts getting the negative exponents, then you get into fractions, and it's that same number. So 5 cubed would be 125, and then 5 to the power of -3 would be 1 over 125, right? So that's how the pattern works, right? 1/3 and then 1/9. So there we go.